All right, geometry, we are getting ready for our Chapter 4 test. So this is the Chapter 4 test study guide. What we're going to do is go through half of this today, and then if you get on the Zoom, we'll finish it out tomorrow during the Zoom. Now, just a brief thing about the test. We'll talk more about this, but for the test, we're actually going to be taking the test while we're on the Zoom call. So you won't be able to really take the test unless you get on the Zoom and get the access code from me and have your computer on the Zoom, okay? So just make sure you get on the Zoom on, I think that's going to be Wednesday or Thursday, and I'll talk more about that today and tomorrow, but just make sure you're getting on the Zoom and following the directions on the weekly agenda, okay? So we're going to go through half of this study guide here, and then we'll do the other half tomorrow. So let's just do the odds today. So it says the following statement is true or false. An isosceles triangle has at least two sides congruent, and that is true because that's what an isosceles triangle is. Two sides are congruent, and that could be two or more, okay? So looking at number 3 says, the following statement is true or false. An obtuse triangle is equilateral. Well, think about an equilateral triangle. Okay, an equilateral triangle has all the same angle. Okay, which means all those have to be 60 degrees. Well, is 60 degrees any of those obtuse? The answer is no. So if it's an obtuse triangle, you got to have one obtuse angle, and there's no way these two can be the same. Okay, so that would also be, or that would be false in that case. Okay, so let's look at number 5. It says classify the triangles giving all possible answers. Scalene, isosceles, equilateral. Okay, so these first 3 are based on sides. Okay, and then the other 3 or 4 are based on angles. Okay, so you have 2 words for each one. All right, so looking at the first one, got 4.8 and 4.8. So that is 2. Okay, so that is isosceles since it has 2 congruent sides. And then for angles, look at this. I've got a right angle, so automatically it's a right triangle. Okay. Same thing here. This one's a right triangle as well, but doesn't have anything going on with the sides. They're all different. So it's a scalene right triangle. Okay. And so let's look at the next 2. It says this one's 1, 2, and 2.5, so that's scalene again. And then it doesn't say anything about the angles, but look at this angle. That is clearly smaller or bigger than a right angle. So that's an obtuse angle, which makes it an obtuse triangle. Okay, so same thing there. It's scalene because the sides are all different there. And 130 degrees is an obtuse angle, so therefore that's an obtuse triangle. Okay, and that's how you classify each of those. Okay, so let's look at number 7 here. We'll come back to number 6. It says find the missing labeled angle. We'll come back to number 6 tomorrow. Find the measure of angle 1 and angle 2. So angle 1 and angle 2. So right here says this is 120. Okay, so remember when there's a box like that, that's 90 degrees. Okay, if this is 120 right here, that is going to be whatever's left since it's a linear pair. Okay, so you can either use that or the fact that it's an exterior angle. So either way, I'm going to make this 60. Okay, because 60 plus 120 is 180. And so to find angle 1, I'm just going to add those 3 angles together. 90 plus 60 plus 1 is 180. Okay, so angle 1 is going to be 180 minus 150, because 60 plus 90 is 150. So angle 1 equals 30 degrees. Okay, so now, kind of looking at the same thing here. If this is 60, this is also 60. Okay, so if that's 60, these are the same. Remember, opposite angles are congruent. So if this is 60, this is also 60. And so what I have here is 60, and that's a linear pair again. Okay, so 60 and 2 adds up to 180. So angle 2 is going to be 180 minus 60, which in that case is 120. And there we are. Okay, so looking at our picture, you got to really pay attention to what's what. Okay, so I looked at the 120 being supplementary to this angle and this angle, and then I used the fact that those two sides were congruent to make everything else the same. Okay, so if you have questions on that, be sure to ask. Let's go to the back side, or the next page. So number 8 says find the value of x to the nearest tenth. Again, we'll talk about that tomorrow. Let's look at number 9. It says, given that EFI is congruent to HGI, fill in the blanks. Fill in the following statements with the correct corresponding part. Okay, so any part that's the same order corresponds. So like for the first one, E goes with angle H. FI is the last two, so that goes with GI. Okay. FE, second and first. GH, second and first. FIE, so FIE, it's going to be GIH. GIH. Okay, so it's just a matter of getting the right order. So EFI is going to be the same order. EFI is HGI. And then the last one, EI is first and last. So HI, first and last. Okay, hi. All right, and that's congruency statements, keeping the correct order. All right. So for 10 through 13, it says, state if the two triangles are congruent. If so, write the congruency statement. So triangle equals triangle is congruent to another triangle. And what postulate did you use? Side, 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 angle, side, angle, side, angle, or angle, angle, side. Which one of those allows you to say that the triangles are congruent? If not, write no or not congruent. Okay, so we're going to look at 11 and 13, and then look at 10 and 12 tomorrow. So in this case, I've got these two sides are congruent, these two sides are congruent. Okay, they've marked those. So I've got S, and then see how they share a side? If they share a side, that's the third side. Okay, so SSS is my postulate. And now I got to say with the triangles in the correct order. Okay, so the left one, I'm going to go ahead and start with F. Okay, so FGH. FGH is congruent to triangle. And I got to go in the same order. So if I started with F, the corresponding part started with the labeled 3 side. So it also starts F on the other one. So F, so this I went F and then out. This is going to be F and then out. So F, J, and then H. Okay, FGH congruent to FJH. Okay, so those are that's the congruency statement for that. All right. So very similar to number 13, I've got them sharing a side again. Okay, so that's shared. So if I'm looking at one triangle at a time, I'm going to look at the top triangle here. Look at what we have. I've got an angle here, side here, angle here. So since it's in that order, that would be ASA. ASA is the postulate I use. And then let's get the correct order. So on the top one, I'm going to start with the one that's labeled with one thing. So S. So triangle S. And I'm going to go to the two labeled. So SPR. So I went SPR for the triangle. Okay, so if that's the case, I got to start with the same spot on the bottom. So start with the one that's labeled with 1, which is here, P. So P, and then I went to the 2 label, so P, S, T. Okay, and that makes all the parts correspond with each other. So P, S, T, which makes sense because R and T are kind of outside of the whole thing, and those are in the same spot, R and T. Okay, so if you have any questions on that, please let me know. Okay, so let's go to the next part. 14, again, we'll talk about tomorrow. 15, in ABC, triangle ABC, if AB is congruent to BC, then which two angles must be congruent? So let's draw our picture here. So A, B, C. So it says AB is congruent to BC, right? Okay, so if that's the case, which two angles are congruent? Well, remember, it's the opposite angles of congruent sides that are going to be congruent. So those angles are A and C. So angle A is congruent to angle C. Okay. That's it. What is the opposite side or angles of the sides we're given? Okay. 16 we'll do tomorrow. Okay, so 15, 17. So 17 says, using the figure from problem 17, classify, so this is the figure we're using, classify the triangle based on sides and angles. Okay. Now, I think it's referring actually to 16. So problem number 16. So we actually do have to look at 16. So given ABC is congruent to KTP, measure of angle, I think it's looking at number 15, sorry. So number 15 from 15. So 15 is ABC is this triangle here that's referring to. So based on that information, what is that labeled as? So it's two sides congruent, so that's isosceles. And then also, since it's isosceles and those two angles are congruent, we don't know what kind of angles there are. It could be obtuse, but since we don't really know, we've got to say acute unless we are told otherwise. Okay? Now, if we were talking about 16, let's talk about 16 real quick. This is 15. And 16, we've got angle B is 83. Okay, angle K goes with A there. So A is 17. Well, think about what that other angle is going to be. If it's 83 plus 17, let's put that in the calculator here. So 83 plus 17 equals 100. So 100 minus or subtracted from 180 is going to be 80. So that third one's 80. So in that case, none of those are equal. None of those are obtuse. So that would be scalene, and that would be acute. Even though it doesn't look like it, that would be the case. Okay, so let's look at number 19 here, and then we'll move on to the proofs. So, number 19, if the following triangle is equilateral, what is the length of each side? So equilateral means these are all the same. So all I have to do here is pick two of them, set them equal to each other to find x. So 4x equals 3x plus 5. Subtract 3x to both sides, I get x equals 5. So if that's 5, now I just plug it in to find what those are. So if 4x is that one, I have 4 times 5 is 20. Okay, so all of the sides are 20. And that would be my answer. This is 20, this is 20, this is 20. Okay, and I can double check if I want. So 7 times 5 is 35 minus 15 is 20. 3 times 5 is 15 plus 5 is 20. Okay, so it all works out there. All right, so last one on this page. This is one of those distance formula problems. So based on the coordinates, determine whether this triangle is scalene, isosceles, or equilateral. So I got to find the side lengths of these, and I'm again using the distance formula here. Okay, so you got to be able to use the square root button. So for AB, or in this case AM, this is going to be x minus x, which is 4 minus 5 plus negative 1 minus 6 squared. So both of those are subtract and square. So that's negative 1 squared, that's negative 7 squared. And so I end up with 1 squared is 1, plus 7 squared is 49. Again, negative squared becomes positive, so you don't have to worry about signs there. And that's square root of 50. So we get 7 point probably 1, but I'm going to double check anyway. So square root of 50, 7.1, round to the nearest tenth. Okay, so now let's go to the next one. MK. Let's find MK. So MK is going to be 5 minus 1 is 4, so 4 squared, plus 6 minus 3 is 3 squared. And so I get 16 plus 9, which is square root of 25. Square root of 25 I know is 5. So there's that. And then the last one is AK. AK. So AK is going to be 4 minus 1 is 3 squared. And then negative 1 minus 3 is negative 4 squared, which in this case is 9 plus 16, which we end up with square root of 25, which is 5 once again. So since these two match up, that makes our triangle isosceles. Okay. And I didn't have to draw it. You can use this obviously if you want, but you don't really have to if you can use the distance formula. Okay. So let's look at the next set of questions here. This is 22 and 23. It says write the 2-column proof. So we're going to do 23 here and save 22 for tomorrow. Okay, so for 23, our given is that AD is congruent to CB. Okay, so let's go ahead and write that one down, congruent to CB. And that is given. So far, I have S. Okay, and then step 2, or the second given, it says CB is parallel to AD. So if these two are parallel, that makes this a transversal. Okay, so what we have is angle 2 and angle 1. This goes back to our parallel lines transversal unit, which says angle 1 is congruent to angle 2 because what kind of relationship are they? And hopefully you're kind of saying it under your breath or saying it to the screen. That is alternate interior. We know they're congruent because if they're parallel, that makes the angles congruent. Okay? And so, looking at our picture, I've got S, I've got A, and look what we have. This side here is the same in both. Okay? It's the same in both triangles. So, BD is equal to itself. BD is congruent to BD by reflexive. Anytime something is shared or the same side on both, you can use reflexive properties. So look at our letters here. In the bottom triangle, got S, A, S. Okay, S, A, S. So I can go ahead and say triangle ADB congruent to triangle CBD. Again, I'm just looking at what we were trying to prove. And that is SAS, or side angle side. Okay? So, last one here, 24. We are going to talk about that one tomorrow. Otherwise, you can go ahead and, if you missed anything, go back, pause it when you get to each problem so you can write whatever you need to down. And then we'll talk about the rest of it tomorrow and get ready for our test on later this week. Okay? Peace.